Welcome back to this event on the challenges of teaching ethics to future computing professionals. Now, as planned, we have a discussion panel. I will briefly introduce the panelists and then asking them just a first question. Then we will have a first round and then a second question, and then hopefully plenty of time for discussion. So I ask our panelists to stay short if they can, so they can allow a general discussion. So let me introduce.
You're on mute, Viola.
Sorry. So, okay. Okay. So let me introduce our panelists. So the idea is to have 2 rounds of discussion and then plenty of time for questions and answer. So our first panelist is Gordana Dodit-Krovnik, is professor of interaction design at Chalmers University of Technology and professor of computer science at Magdalena University in Sweden. And her research focuses on the relationship between computation, information, and cognition, including ethical and value aspects. And she's a member of the AI Ethics Committee at Chalmers at the Karel Capet Center for Values in Science and Technology. Then let me introduce Paul Gibson. Is currently working at Télécom Sud Paris, France, which is a part of the group of the Grande École Mind Telecom. His research has examined a wide range of issues, including formal methods, object-oriented modeling, software product lines, services engineering, e-voting, models of computation, innovative teaching techniques, and computer science education in school. And his current interests include digital ethics and ethical systems engineering. Then we have Damian Gordon, has been a lecturer in computer science at the Technological University of Dublin for over 20 years. He has a wide range of research interests, including the study of ethics of a computer system, the security of mobile applications, the application of computer vision, the universal design of educational system. And he's author of many research papers, contributed to books in very diverse topics, such as the use of archetypal characters in Victorian literature, the ethics of data system, the development of industrial-oriented educational programs. And then we have Andrea Carli. He's a lecturer in the School of Computer Science at the Technological University at TU Dublin. She served as course coordinator across all postgraduate programs in the School of Computer Science over the last 10 years, and has been involved in setting up a number of these programs from the beginning. Currently, she is the Master of Science course coordinator for all the master's program in the school, and her main area of interest lies in the fields of user experience design. So basically, we have in this panel all some of the people that within the Ethics4EU project are involved, in particular in the development of the so-called educational bricks, the intellectual output number 3 that Dimpa mentioned before. And I think that it's interesting because if in the first part of our event, we have, in particular with Julia talk, we have been the perspective of people coming from the humanities in teaching ethics, in particular to medical students. Now we have the perspective of most of the panelists are coming from computer science, and then we will focus on this perspective in this part. And then with the discussion, we'll try to integrate the different perspectives. So I think that we can start with the first question I want to ask. And I think it's important to focus on which is the main reason, main advantage, main benefit to teach ethics to computer science students. So we have seen already some of the proposal by Dimna and by Julia. Now I will, I think it's interesting to discuss these questions starting from Gordana with our panelists. So Gordana, please go ahead.
Thanks a lot, Viola. It was really exciting to be part of this event, and I'm very happy to be a part of Ethics4EU as well, because it is my dream coming true. After 20 years of teaching ethics in different universities, technical universities, I was always dreaming about having this systematic approach, system support, many people working on this project and so on. So now it is happening. And why I think it is important, both Dimna and Julia mentioned many reasons, and I would emphasize we are now in the process of digitalization, introduction of AI, massive technology, Internet of Things and such things. So technology is becoming pervasive, and it contains components which are intelligent. So for us as society, as user of this technology, it is very important to understand technology and its ethical and societal aspects. And why are engineers very important in this context? Julia mentioned that we have these interdisciplinary groups of people collaborating and co-producing knowledge. And we have included both people from humanities and people from domain expertise. And why are engineers so good? Because the engineers are problem solvers. So when philosophers says, there is an unsolvable dilemma. We have two opposite things and we cannot get the best solution. Engineer would say, okay, we have two constraints. How do we solve those constraints? Or if we have even more constraints, they would say we have multi-criteria decision analysis. So we will take many of those criteria and try together to understand how to solve the problem. So that's the first thing, they are problem solvers. And the other is they bring the knowledge from inside of those technological systems. So no one knows better than the engineer how this program and how this hardware is working. So they can help the interdisciplinary team with this part of knowledge as well.
Okay, thank you very much, Gordana. I think that Paul and then Damian and then Andrea, and then we'll remove order. So Paul, what's the main reason to teach ethics to computer science to students for you?
Hi, Viola. I just checked, is my sound and my video working for you okay?
Yes.
Okay. Hi, everybody. I'll just start by saying I don't know whether it's ethically a good thing to use a photograph for me, which is nearly 20 years old. But I'm not complaining, as you can see from my gray hair. Okay. I guess the question about the main benefit or advantage for teaching ethics to computer science students, I'd maybe like to make it a little bit larger. First of all, I think the general thing is why do we teach anything at university? Why do we teach any subject? And I think one of the main reasons that we teach is to benefit society. So it's not just about transfer of knowledge and extending knowledge, but I think it's how we use this knowledge to benefit society is why a lot of us get into teaching. And I think sometimes when we forget the kind of foundations of this notion of benefiting society, this can sometimes have a negative effect on how we teach and what we teach. I think from my own background, I don't have any research experience, particularly in ethics. I haven't done any ethics education, but my own background in safety critical systems, when you're developing software or systems which are safety critical, you have to think always about the impact on the systems, on the users and on the environment. And part of my training in sort of formal methods and rigorous mathematical modeling of such systems sort of led me to think about ethical issues without realizing that I was thinking about ethical issues. And so I think it's very important when we're teaching computer science students that we not only teach them sort of general ethics, but we also teach them that that their particular use of technology and their particular development of software and technology can have a real benefit and harm to the environment in which this technology is going to be used. I think it's also important not just to think about teaching digital ethics to computer science students, but now I think it's very important to teach digital ethics to all students. As part of my teaching, I teach students outside the computing discipline, and a lot of them have very challenging questions about digital ethics because they don't understand the technologies. And so I think one of the benefits of teaching ethics to computer science students is that they will also be able to talk to their colleagues outside the computer discipline and bring this additional knowledge they have about the technology and the engineering aspects back to their community, back to their fellow students, even back to their families and friends. This has become particularly important now, I think, particularly with COVID, where we're now talking about things like anonymity of data. And in general, even young children can understand the notion of anonymity of data. But when you're talking about anonymity of data, there's so many different definitions of what it means for data to be anonymous. And it's only really the technical students, the computer science students, the engineering students, even the mathematics students, who can really differentiate between what is being claimed for anonymizing the data and what is actually being done. And so it's very important that as a sort of a value to society is that we educate our students in order for them to be able to better communicate to the people that they're interacting with. From a point of view from the computer science students, I think one of the phrases that means the most to me in terms of teaching ethics is that I think it was Grady Booch, who's a very famous software engineer. He wrote something which included the line, "Every line of code matters." And the idea being is that we be teaching our students that in computer systems, this is absolutely true. We may have a system with millions of lines of code, but in fact, one single line of code or even one single character in a line of code can have a major impact on individuals or on society. And I just give you one very simple example. There was a line of code in a banking system which had a less than or equal to sign instead of a less than sign in it. And in fact, out of the 20-odd thousand users of the system, it only impacted 6 of them whenever we did some tests, but the impact was to do with payments for social security payments. And what actually the impact was that 6 people, instead of getting their social security payments on a Friday, had to wait until the following Monday. And that was because of a single line of code. And you may think this isn't really important, 6 people out of over 20,000. And in fact, our quality assurance tests told us that statistically the system was very, very good. And it was only when I started thinking about the ethical aspects of the system is that the environment isn't just a sequence of numbers and statistics. These 6 people who had to wait 2 or 3 extra days for a social security check, that could have had a very major impact on their lives. I think this is the thing that we need to teach our students, is to be empathetic to all the users of the system and not just to treat the analysis of the systems that we're doing based on mathematics. And I just want to conclude by saying that I think I can repeat something which was said by Newton this morning, is that my own work in software engineering and training software engineers is we teach them in the beginning about how are we building the correct thing? Do we really understand the requirements? And then we teach them about design and implementation. Are we building the thing right? Are we using the technology right to meet the requirements? And it's only recently in the last 3 or 4 or 5 years when I've become interested in the ethical aspects of it, is that we should actually start off by thinking about whether we should build something at all. I'd like to sort of emphasize this, that I think this is the most important lesson that we can teach our students and our computer science students. So I'm finished.
Okay, thank you very much, Paul. Now, it's Damian's turn. I don't know if Damian can speak. So maybe we'll pass to Andrea and then move back to Damian. So Andrea, what's for you the most important element in teaching ethics to computer science students?
Yeah, hi everybody, and thanks to Dimpna and Julia for really interesting conversations earlier on. They were excellent. I suppose for me, with all the ethical controversies that there are, that has to be a starting point. And as an educator, to see these happening. That's a flaw on us, and how can we improve that? I've just finished watching a Netflix series, The One. I don't know if it's available to anybody, but I suppose that there's a major ethical dilemma in the whole point of the program. And it's a matchmaking service that uses DNA analysis, but actually right throughout it, there's loads of ethical dilemmas within it. And it sort of got me thinking, you know, while it's a bit fantastical at the moment, what are the decisions that our students are going to be making as we're moving on? And, you know, we are responsible for this. I kind of feel that technology is moving so fast, but consideration of ethical implications or ethical reasoning has fallen far behind. And, you know, I will stand up and say, like Paul, I haven't considered ethics really until the last few years, until I came into this project. And I've been involved in, you know, interface design, programming, web development. And I've never really asked the question, again, as Paul said, what can you do? But actually, what should you do? So like, I taught first years in algorithms for a number of years, and all they wanted to do was code, and they couldn't see beyond their C programming language, which they were learning at the time. And to try and abstract them and think about the design, and I'm not including ethics here, was really difficult. However, because this was considered in so many modules and brought right through until the end of their course, by the time they get to their dissertation, they really understand that they need to do this, the methodology, the design, and everything else. And it kind of got me thinking, well, really, we should be doing this with ethics, you know, as part of design from the very start, and that it's in a number of modules, not as a separate module, because we all know that they'll just tick that box and go, I'm a software engineer, that's not for me. But if they hear it all the time, by the time it should be evident to us when they get to the dissertation that they're considering that without us having to say it. And more importantly, when they move out into industry, that they're making the correct decisions, that they're thinking about, you know, the societal impact or the ethical reasoning behind the decisions that they are making. So I think it is our responsibility to instill this mindset into our students and do it better, I know from my perspective, than I have been doing it up until now.
Okay, thank you very much. I don't know if Damian is here. I think he's having some problems in joining us. I don't know.
Be okay now.
Okay, Damian. So go ahead. Thank you.
Just for me, I absolutely to follow up on Paul and Andrea's points. I think for me, the worst thing about computers is the disappointment it is, really. They had so much potential, so much hope. I think in the 80s and 90s, it seemed like computers would be a good thing and a positive force in the world. And they just failed miserably. And that, at best, computer organizations say, well, technology is value neutral, as if that's a good thing. Whereas what we should be embodying and imbuing technology with is goodness and kindness and consideration, and make things like cyber harassment impossible. So when people develop software, when people create computers, it should be a ceremonial and ritual thing they're doing. It shouldn't be treated as a job or a business. It should be considered the highest, most important thing you do. Brady Booch, the software developer, said every line of code is an ethical and moral decision. But I agree with that, but I think more so, every program somebody writes embodies and imbues some of their philosophy and some of their perspectives on it. And I think if we get people to write software in a hurry, and we get people to write software unhinged and unmoored from their ethical core and morals, we end up with very poor software and very poor experiences for people. I really believe software can be great, and it can be kind and can be helpful in the world. But I definitely think we're falling so far short of the promise of what early computer pioneers would have imagined we would be at this stage. That's kind of it for me.
Okay, so thank you very much. And I see that already many elements are emerging, and I guess that one of them is in particular the challenges of this form of teaching, of this form of integration, that goes to interdisciplinarity in general, but then also goes to very specific issues, like, for example, how we should integrate, I don't know, a course with different instructors coming from different backgrounds, or even have also how is it possible to have mixed classes, for example, like with students, some students that are really experts in computer science, and they can know some details, and they can also, let's say, support other students in knowing better about these technical details. So there are many issues that are worth discussing. So I would like to have a second round and then open the debate. And the second round of question to our panelists is in particular about the challenges. So let's start from Andrea, and let's ask her what is for her the most important or the most serious challenge in teaching ethics or trying to integrating ethics into computer science curricula.
Well, I suppose the first question has to be, how is it going to be integrated? Are we going to do it as a standalone, or are we going to incorporate it? And I suppose previously what I spoke about, my obvious preference is to incorporate it within modules. And as Julia mentioned earlier, that's what's been done to, you know, really great success in Harvard, and research would say that's the better way. That's easy to say. How then do you move along and get it integrated? Because it needs to be in a number of technical modules. So you've got a lot of lecturers involved there. Most of us haven't considered this for a long time. So, you know, who is actually teaching it? I know for me, when I teach something, it has to mean something. So, you know, the whole case study approach that we've been working on in Ethics4EU is obviously a very important, certainly for me, I wouldn't have the confidence really that, you know, to give my students the knowledge that they actually need. I suppose we need to get the students and ourselves away from the thought that it is an add-on, you know, that it is part of what we do from the very start. But I think the biggest thing is, how do we integrate it? How do we educate our educators to bring that across to our students?
Okay, thank you very much. This training the trainers is, of course, one of the core of the Ethics4EU project, but also I think is one of the challenges that we need to deal with it today. So Damian, what's your opinion? What is the most important challenge in this kind of integration, or difficulty, or problem, or issue?
I think that's a great question. And you made an excellent point about integrating people from different class groups. It's something I do in some of my courses, and I find it so rewarding for the students to meet people from different disciplines, because they think in different ways, and getting them to do group work together and getting them to work on case studies can be really effective. It also is the case, I suppose, for many computer science classes still. There's a significant majority of the classes who are male and young, and they're just a bit silly and a bit macho still, and trying to show off a little bit. So to try and break down those barriers and to, again, encourage empathy and understanding and kindness are really important work. We do work with some organizations, disability organizations and charity groups and things like that, and we find it helps students blossom as people when they realize, I can help other people and I can make other people's lives better by using this technology. So I think the more we give them opportunities to win, and to win at being good, the better are the kinds of technology, and the more they'll consider ethics as part of their professional career.
I think this is a very important point, and it's even controversial in the sense that it's very important that we include ethics as part of the professional, abilities that future computer scientists must have. At the same time, and I agree with you that empathy and also trying to have students that flourish as person is very important. At the same time, this is kind of controversial, or maybe can be controversial in the sense that it leaves the idea that ethics is just a part of a personal attitude that cannot be taught or cannot be considered in a let's say in a more rational way. I leave it open for the next discussion. So now I want to hear from Paul about the challenges, about the difficulties of this idea of teaching ethics, or better, of integrating ethics into computer science curricula.
Hi again, Viola. Thanks to Damien and Andrea. When I read that we were asked to think of only one thing, I was quite challenged. So I have a short list of 4, but thankfully Andrea and Damien have already taken 2 of the 4. Maybe I can just say a little word on interdisciplinarity, because this was, I think, one of the key things for me is now I'm finding that students nowadays are too focused on very specializations within the discipline. So even within computer science, I sometimes get students who have only ever studied computer science at university. And I can remember sort of 20 or 30 years ago, we used to get students who were getting a much wider range of things, coming with some of them did literature, some of them from humanities, some of them from social sciences. And I think it's very hard to teach interdisciplinary when the students have not ever been taught within an interdisciplinary environment. And I think Damien's notion that the people from the origins of software engineering 50, 60 years ago would be disappointed with what they see now. I think that's because a lot of people in software 50, 60 years ago weren't computer scientists, they weren't software engineers, they came from sort of philosophy backgrounds, mathematics backgrounds, engineering backgrounds. And so one of the big challenges for me is I think interdisciplinary approaches are necessary, but we need a lot of thinking about whether we can actually do interdisciplinary teaching if the students aren't used to this sort of way of working. So that's kind of the first thing I'd just like to say. The second thing is on empathy. I think one of the things I also think is very important is this notion of empathy. But one of the problems I'm seeing with students nowadays, and not just in France, but in other countries, is that they've got a notion of competition is built into their education framework. And everything is competitive rather than being collaborative and cooperative. And so we get this loss of empathy between the students, but also between the students and the society or the environment in which they live. If everything is about you competing and doing better, it's very difficult to be empathetic with the other people or the other parts of society. So I think empathy is really important, but we need to change the way in which students think about education. And I think we are far too competitive now, and that's a big challenge for me in education. So I come to my own final term, and I'll be very quick. I think the one thing that I find really important is responsibility. And I think Julia talked it today, this notion of we can teach the students to be responsible for what they do, the code that they write, the systems that they develop and the design, but we also need to make them responsible for the things that they don't do. So they don't speak up in meetings when somebody is sexist or racist. They don't speak up whenever they think there's artificial intelligence bias. And so we need them to think about their being responsible for their inaction and not just responsible for their action. And that's very hard to teach. I mean, I think it's easy to teach. You write this line of code. So what are the implications of this? But it's very hard to teach what are the implications of not doing something. And for me, that's also a big challenge. I think I took too much time, but thank you.
No, it's okay. It's okay. Thank you. And I think this idea of responsibility that is connected not only to action, but also to lack of action is really a key element. So let's conclude this second round with Gordana. I think it's important to emphasize that Gordana, she started telling us that her dream is coming true. And it's very important to emphasize that Gordana has worked for many years into the intersection of different fields. And I think that in a sense, she has a unique preparation in this. So we are curious to know about your difficulties. What do you think about these challenges?
Thank you, Viola. I think for me, one point is really crucial, and that is participatory pedagogy. That we do this course or courses or lectures together with the class. That the class takes this message and internalizes and brings it with them to the industry, to the companies, to their future professional life. as I was teaching in 20 years time, different sorts of engineers, I have this experience of people coming from industry, coming back to me and saying, I discovered something, I would like to solve it in some way. So they come with a proposition, for example, to introduce ethicity like non-functional property in software engineering. Or ideas, you know, people take it as really seriously as their own project, and they bring it further. So this participatory ethics, so that they understand it's not me who knows who are right and they are wrong and I have to teach them to be right. But we share our knowledge even in the class, because today they have access to information. They have a lot of knowledge, and especially in classes which are mixed. And I would also like to say that courses in ethics are good things. They are part of ACM IEEE curricula, and they are opportunity, as you said, Viola, you can take interdisciplinary teachers in one course and give one specialist one lecture or lesson, and give them many different fields to cover. And then you get in the same place this interdisciplinary atmosphere and opportunity for the class to discuss, to collaborate, and so on. So I would say that having courses do not prevent us from having lectures, particular lectures in different courses. Course in ethics is something completely unique, and I would like to have courses in ethics like courses in mathematics, you know. We have pieces of mathematics in all our technical education, but that's all just small pieces. But then you have courses in algebra, in differential equations, whatever, you know. So I think courses in ethics are a very good thing if they are possible.
Okay, thank you very much. So I see, I will unshare my screen. I see that there are already a lot of comments and questions in the chat. So I don't know if maybe if Michele Loi wants to start, you can use, if you feel you can use your microphone and to ask your question to the speakers.
Thanks, Viola. So the question is generally, how do you deal with positivism? I mean, the fact that there's a background assumptions, I think, in many students that just get reinforced by the way they are taught and without much philosophy. That there is the world of fact, the world of objectivity, and that's what they're supposed to learn. And then there is the world of value, which is a matter of opinion, and so basically, as serious future technologies and managers, they're actually supposed to rely on facts and what can be measured, and not these other vague things like values and principles. How do you deal with this general mind frame that maybe it's in the background of lots of students, and we actually even don't know much about it, how much it is?
So maybe Gordana wants to.
Yes, I would just comment in the sense that values are not so vague as one might believe. For example, in the field of autonomous cars, we have a list of value preferences in case of cars. In a specific domain, you can say that, for example, safety or human life or whatever is the highest value. And you can make those lists and compare what you have in your concrete situation. So value-based design, that's something that exists already. And it's concrete, it's not...
I know very well. I mean, the point is, I'm saying that I think that there is the idea of value-based design is an oddity in terms of, I think, the general zeitgeist that is absorbed by the student, because most students don't study the philosophical premises that leads to something like value-driven design. I think most students in technical and scientific university scientific subjects, they would start with a much more naive fact-value distinction that basically places value in the realm of opinion and everything else in that, and to fight against that just by teaching a few courses of, let's say, value-driven design, it's probably not sufficient. It's required that there is probably some sort of deeper humanistic education of the technologists so that they don't even absorb this picture, which we know philosophically. I mean, this kind of positivism, nobody buys into it, but the person who's not a philosopher, who's not a social scientist, may actually have it may be the default view of such people. Of course, it's not my view. Exactly. You don't have to convince me. My question is how widespread is it between technologists and students of technology outside of our departments and so on.
So maybe Damian wants to add something to this.
I think you're absolutely right in terms of it's the regrettable fact that any student could go through a course and learn the content and never learn the values associated with it. What I do find as a computer scientist, though, is most of the problems I grapple with, I do a lot of work in image processing. We're trying to teach the computer to understand images. Most of the problems I deal with have been solved by philosophers about 50 to 100 years ago. In AI, the issues that are coming up now have been not solved necessarily, but there's good models and good perspective and intelligent thoughts already put into it. So incorporating some philosophical input into computer science means lots of problems that we think are really hard to solve are really, really well thought out by somebody else. I don't know how, I can't think of any discipline within computer science where some philosopher from 100+ years ago, or even from the last 50 years, just recently I had a problem and all I had to do was look at Wittgenstein and was like, oh, okay, that's how you solve it. I get it now. So just to even start with the recognition, Paul said it, that a lot of people who come into computers initially were coming from different disciplines. And I think that was such a rich and better environment because you were getting people who didn't think they were going to have a career. And that's, I think, a real problem nowadays, that students are taking these qualifications because they want a good career. And it shouldn't be that at all. You're creating something, particularly there's probably 100 20 to 30-year-old white guys in America that are dictating, that are controlling millions upon millions of young people's lives because they make choices about what they see on their social media. They make choices about what pictures are recommended on Instagram. So a very small number of people. So I think general self-defense about technology should be taught that people, to younger people, to protect themselves from technology, but also a recognition that the problems we're thinking about, how to model worlds, how thinking works, how perception works. These are things that since the pre-Socratic philosophers, Heraclitus and Zeno and people like that, have been thinking about this for a long time. So we should copy our work. And I know it's wrong to copy your homework, but I definitely think in computer science, we should be copying our homework a lot more, and we should copy from the grades because there are good models out there in philosophy and ethics.
Viola, you're mute.
Sorry, I'm just collecting the questions. So we will have first Simona Motonia, then Martin Taka, Christina Klaas, Christina, I cannot see your surname, sorry. And then again, Gonzalo Genova. Okay, is it okay? Because I missed the first question by Simona Motonia. So Simona, if you want, you can use your microphone and ask this question. Or
I was... Hello, I'm from Romania, Cluj, and I'm teaching an ethics course for computer science undergraduates. And we have also extended our ethics component to master students, where we dedicate more topics to research in computer science. So I would like to find out your opinions about also thinking at this part, not just for future practitioners, but also for researchers. Does this pose any supplementary problems? Thank you.
So
I'm happy to jump in. I definitely think
okay,
it's
go ahead.
significant issues. I think it will be fair to say every choice a researcher makes has an ethical component to it. I was speaking to a class last night talking about how there are software systems in America that help judges sentence criminals. They take all the data from hundreds and hundreds and thousands of cases and then recommend to the judges, this person is likely to reoffend, this person is likely not to reoffend. One of the choices they made was they included one field was the race of somebody. And what has been found over and over again is these systems are very racist. Gender is another field they chose to include in it. They've found that these systems are sexist, but it's okay because they sentence women less than men, which has got to be good. Come on, that's not too bad. But still, somebody made a choice when they were putting together these data sets to say, let's include race, let's include gender. They didn't have to, they shouldn't have, but they did. So I absolutely think where you have case studies that illustrate the severity of the decision versus the consequences. And I do really believe, even if the students understood the basic perspectives of philosophy, my three are deontology, value ethics, and utilitarianism, or even consequentialism, just even understand that whole area, then at least you know you're looking at things like consequences versus decisions, consequences versus choices, and what is the true good. To think about things like that, I think are really important for computer science students, particularly as we're in an era of data analytics now. So many students who are doing research think that I have a bag of data, let's dive in there and let's see what we can find, which is exactly the wrong way. And the approach should be, what are we looking for? And then let's go to the data for next, rather than just have a shuffle around and see what we can turn up, because it leads to very dangerous and very superficial conclusions. Computer science researchers should follow the scientific method as we understand it, that they start off with a hypothesis. They don't start off with the, we'll see what we can turn up. And that to me is a big issue.
I guess that Paul wanted to add something to the previous question. So Paul, go ahead.
Yeah, I just wanted to make a comment on one approach that I find very useful in addressing the difference between values and facts and introducing ethics. It's problem-based learning. Nearly all my teaching now is based on case studies and problems. And most software engineers learn very quickly with problem-based learning that there's no one solution, there's no correct solution. And in fact, the evaluation of how well you've done is based on the different criteria and the different weighting of the criteria. And I often get the students to give me their own evaluation criteria. And often the criteria they come up are value-based. So they come up with their own value-based criteria and say, it's important that this doesn't do harm, it's important that this, etc. And so this is a really good technique, is to integrate problem-based learning with value-based criteria in the actual evaluation procedures. It's about the only technique that I can confidently say I am using and is working, but it's quite a simple thing to do. So I just thought I would pass that on to you. And I have a comment to make to reinforce, I think, what Gonzalo said. It's very important that when you're doing requirements engineering, which is one of the things that I teach, and I've been teaching for 20 years, requirements are not facts, and that is really very important. It's very important that you differentiate between the axiomatics in your systems, the assumptions, and the requirements, and not to make the mistake that a requirement is somehow or other something factual. But that's something that any good requirements engineering teacher will teach anyway, I hope. So thank you for that comment.
Okay, thank you very much. I guess we can move to Martin Takac. I don't know, Martin, if you want to say your comment.
Yes, so that's basically a reaction to participatory pedagogy, because I have an experience with teaching students that have interdisciplinary backgrounds, and in there it's really key as a teacher to have a belief that students know and they have knowledge, and just dragging them in the discussions because they have their background experiences from their disciplines, and they can teach each other. So the teacher is more a facilitator of the discussion, who's asking questions and posing perspectives, but it's not about telling them what's right or wrong, because that's basically killing discussion very often. And just one more comment, that I discovered that students with different backgrounds, they have different blind spots. Like if we expose them to papers from different disciplines, students of, let's say, psychology, when they encounter paper with mathematical formulas, they get stuck. But computer science students or mathematics students also have their blind spots. When they read a philosophy paper and I ask them, what's the main idea? And they say, I don't know, nothing, it's just talking. They are not used to something that's not very exactly formulated. So it's great to keep these differences in mind and use them for advantage, for enriching it, rather than, blocking the teaching.
Thank you very much. Does anybody want to? Okay, Damian.
Just to follow up on Paul's point and Martin's point, I think part of a third level experience should be to get a fully rounded university experience. So to be exposed to ideas that are things you're familiar with, but things you aren't as well. It's so important to expose people to different ways of thinking. One of the most enjoyable parts of the university experience for me was I finally hung around with people who were exactly like me, had the same tastes in books and movies and the same style of thinking. So then when I did meet people from other disciplines, it was such a really wonderful experience to realize, oh, okay, there are other worldviews and there are other points of view. Definitely when your teachers think like you, your lecturers, everybody in the class thinks like you, the guest lecturers come in, everybody thinks like you, it does tend to create a kind of groupthink problem where there is no other point of view, and just always bringing in critical outsiders is so helpful in these situations. Completely agree with Martin.
Okay, then we have Andrea, and then Christina Klasse. So
yeah, I just thought, I totally agree with what Martin is saying there, in that I teach an MSc course, and often there's a number of PhD students from completely different areas, and it's amazing what they bring to the class, that, from non-technical areas, because like Martin said, the blind spots, I would say, even from my point of view, it has really opened my mind. But I suppose it highlights the issue that I said maybe earlier on. How are we teaching ethics to undergraduate students? Because they're coming in, we don't have that rich environment where you have people with experience from diverse backgrounds. They're, mostly, I know for us, it's 18, 19-year-olds, students that have been coding since they've been, children. And how do we teach that, I think, is a much bigger problem than, sort of a problem-based approach in a more diverse course or module.
Okay, thank you very much. And then Christina Klasse, and then we have the other Christina, sorry. So Christina.
Thank you. I would like to add, I have an experience of teaching in highly international environments, computer ethics. And this, sometimes students feel lost, especially students at the bachelor level, and they want to know somehow a way to go and answer. And the point is, I can deal with this uncertainty of the students, and I can try to help them and tolerate. But we are talking now about trying to do the train the trainer, of giving possibilities of teaching people or helping people who are from a technical discipline and who are maybe not used to this. And I think there the problem aggravates. They might also not be prepared so much with this kind of discussion. And I have also a friend coming more from the American background. And sometimes we have very heated up discussions because she comes from her utilitarian system and I'm a German and I'm very Kantian deontologically. And this is things, how can we prepare teachers in a not too complicated way to deal with this and to give good answers to students and help them also to tolerate this, because CS is a highly international area. There will not be the answer, and it's about more than just one software. It's about a whole system when we talk about the internet, and this is a big issue, I feel.
If I can answer just, I mean, a comment. I think this is very important and interesting, but sometimes it's even enough that you make these theoretical frameworks explicit. And sometimes, I mean, to discuss explicitly, to put on the table in an explicit way can help to recognize and then to discuss whether we want to accept some let's say, axioms of the different ethical frameworks. I don't know if someone wants to add on this. Otherwise, I will move to Kristina Vasilevska, who is waiting. So go ahead, Kristina. Sorry.
Hello. Hello. Yeah. Thank you very much for your insightful takes on on this problem. And I just wanted to kind of tune in and say that as a computer science educator with a computer science background, no philosophy, nothing like this, I also very much know how computer science students are treating, more philosophical kind of subjects. And although, yes, I agree with Gordana that there should be an ethics course in every computer science curricula included, I also know that if the importance of this course is not underlined, is not the building up parts of the ethical dilemmas are not brought to the computer science courses, the other courses that our students are experiencing. If they are not communicated in the same language of these computer geeks, by the people that they know, that they respect, and these people are telling them, okay, guys, this is important. Because I was listening for some of the speakers earlier about and heard so many philosophical terms I'm not familiar with. And I mean, I'm the person who wants to teach ethics to our students, and I try to actually make them aware of it. And I was lost as an educator, which is actually just underlines the importance of the Ethics4EU and all the other initiatives that we as educators should be familiar with, or given the terminology, but it's also important that we don't lose ourselves in more other disciplines, but we still continue talking the same language as our students. Thank you very much.
Thank you. Maybe Gordana wants to answer this question.
Yes, I think it's a really important point Kristina is making. If we do not get support from our colleagues, from our profession, it's really very hard to work against the stream. But now we are getting much more support from all the sides. For example, from big tech. Even Google has their own ethics rules and ethics policies and ethics experts. They recognize ethics is important. Everybody recognizes verbally it's very important. And people are accepting that ethics is important. So how do we teach? I think we come in as a project there to help people with vocabulary, with all the practical parts to facilitate teaching ethics in Europe, to making it easier for our colleagues.
Damian?
Just to throw in, and I don't know if this is helpful or not, but at least we're not engineering. So at least in computer science, we have the concept of phases of developing content. So we have a design phase, and part of the design phase is we think about both, and Paul alluded to this, the requirements to build the system, the functional requirements, and we also think about the non-functional requirements. And in a way, that is what are the values of the organization we're building the software for. So every company buys and sells things. So you would think you could just use, every company should use the same accountancy package, the same software package, but they don't, because every company has their own ethos, their own USP, unique selling point, and they believe that their software should be embodied with that unique selling point. So within our design framework, we already have the notion of non-functional requirements. What values do we want to embody? So I think at least we have a place that ethics can sit. And I really do think when some people think about computer science, they think of it solely as programming. And that is the last thing a computer scientist is about. Computer scientists are about designing good, working, functional software. And the design part, I think, is the most important. But before you start the programming, these decisions need to be made. Even earlier, when you're figuring out what does the user want, to have serious conversations with them about what's their ethical position on things. So it's just a matter of saying at each stage, at the figuring out the requirements, at the design, at the build, at the test, at the evaluation, at each stage, that there's an ethical component imbued in the approach. We would say methodology. So we've a lot of different software methodologies. And it's exactly Christina's point. If we can speak in the language of the CS geeks, if we say it, okay, ethics, it's just another requirement we add in, then we have a real chance, I think, of making it central, but not dominating.
Okay, thank you. I think Gonzalo already raised some issues in the chat. So Gonzalo, if you want to use your microphone.
Hello. Can you hear me?
Yes.
No, I simply say, I think I have put my considerations in the chat properly and they have been answered and received. So there are still very few minutes. So I pass my turn. Thank you very much.
Okay, thank you. So we can move to Yannis Stavrakakis, and he had a comment or a question in the chat. So Yannis, I don't know.
Yeah, hi.
Okay.
No, more just more of a comment than a question. About basically even in the hard sciences and in theoretical physics and stuff, there is the principle of uncertainty. So there are no definite answers there. Quantum mechanics says that, you know, we cannot be certain of anything. So that, as a philosophical principle in science education, could maybe help in educating students in philosophical concepts that are borrowed from the natural sciences. That's basically it. Thanks.
Okay, thank you very much. I guess that Christophe Mudek in the chat, there's a question. So maybe Christophe, if you want to open your microphone and ask the question, or I can read it for you. The question is, how do we deal with valid statistical models that lead to unfair individual decisions? Is there a way out, or such systems be banned entirely in the case in which the likelihood to reoffend predicted grade is?
Ban them all. That's what I say. Ban them. Look, I definitely think. Again, philosophers have answered this question in a sense, and legal scholars. Rawls' idea of a veil of ignorance. If you had to design a system where you don't know who you are going to be in the system, so if you don't know if you're going to be the criminal, the judge, or the defense or the prosecution, how do you design the system then? So if we can get the students to consider themselves as being the victim of this thing, and I definitely think I saw a very moving documentary about family members who were discussing their family members who had been unfairly or wrongly accused or wrongly sentenced because of errors in software. So I think to create a human experience, but I definitely think Rawls' idea of a veil of ignorance, that how do you design your system and you don't know who you're going to be in it, is such a great concept and such a simple thing to help students think about how to do it. I think if there's any unfairness in the system, it's an unfair system. So for me, and I know that's an extreme perspective, but for me, if there's any unfairness, then we couldn't call it a valid approach. Statistical models are just that, they're models. The same as a toy train is not a real train. The same as a toy elephant is not a real elephant. A statistical model is a representation of, but it's a very simplified representation of reality. If we're building systems that have real consequences for real people, We can't rely on simply models because they don't take into account the exceptional cases. And we know from basic statistics that in 1 in 20 cases, there's an exceptional case, because that's 2 standard deviations from the mean. It's the 5% in either tail. So that means 1 in 20 times in any reasonable statistical model, something horrifically bad is going to happen.
Okay, thank you. I think we have a comment from Helen pointing attention to the way in which they do this. They try to solve these challenges at the University of Tartu, Estonia. So Helen, if you want to use your microphone.
Sure.
I don't know. Okay,
Sure.
go ahead.
I'm happy to explain it a bit. So we brought a legal students who were already advanced students and computer scientists together, and we gave them assignments from practicing lawyers from the Bar Association as well as public sector, the Ministry of Economic Affairs and Communication. So we did a lot of prior work figuring out what are the current tasks that they need solutions for. And then we gave those assignments to those teams of lawyers and computer scientists, and they really needed to figure out the ethical dilemmas they needed to resolve in those cases. But it was very motivating for them because they felt that the solutions that they offered, both the technical and the legal ones then in their teams, they really mattered. So they were very motivated in learning because they were heard eventually, and what they learned eventually mattered for the decisions that were being prepared in the public sector, or what the lawyers eventually used in advising their clients. So there are a lot of very nice challenges currently, which help to employ the ethical skills and the background. So I would advise that approach. We've used that for years now, and it's really working. And the public sector, as well as the lawyers, the practicing lawyers who are giving those tasks, they are very motivated in giving them to the students, because they do need the new look on those challenges, and they feel the students can provide that. So it's worked out very well.
Okay, thank you very much. So I see that the chat is already very active and a lot of messages and exchanges. Also, Gonzalo suggested some very interesting papers. So does anybody want to ask or add some comment? Okay, Gordana, go ahead.
I would add just a very short comment that you can have machine learning from people who are biased, and we are biased in many fields. They are correct programs, they are learning from us, and they get biased. How do we solve the problem? There are ways how we react to biased programs.
Could I come in for a second as well, Viola? Just on
sure.
The point about statistical models there. I think we have to get much better at the concept of explanation and building explanation into smart systems, being able to be transparent to users about how a system reached a decision, why it's making this decision, what data is it using, how is it combining the data. I think this is a huge area going forward. In artificial intelligence, some people are calling it explainable AI and so on, but it's much more than sort of, you know, just explainable AI and, oh, here's how a system reached this decision. I think we need to go back to the users. I think we need to look at mental models of how users interact with systems. It's very different for a system, for a user interacting with a, you know, maybe a social media device versus a smart home system versus a news filtering system and so on. We need to understand how users interact with systems. We need to understand how users understand systems in order to be able to provide these kind of rich explanations about how models reach their decisions. And I think, you know, we're seeing a move towards that with the right to explanation and so on, built into GDPR. But I think, again, this brings it back to the human in the loop in decision making.
Thank you very much, Dimitra. I think, many issues were raised. Of course, there's no way to just try to conclude in one single way. But I think that one important message coming out from our discussion is precisely that we should try to avoid the idea that we can solve all these issues or some of the issues raised just by technical means and adding technical solutions to problems that are just partly technical. So that's very important. And this requires a change in the mindset, not only of the students that maybe are more permeable and more, let's say, attentive to all these issues, but this requires a mind change in the trainers, instructors. So in us, people that come from disciplinary silos and try to make all the efforts to get out from these disciplinary boundaries. So I'm sorry that our time terminated. First of all, let me thank you, all of you, for this event. I think it was good also that we had some time for the discussion. I think that we can save a little bit the chat if it's possible, because I think it will be useful for us in the project, but in general for future discussion. I invite you, if you are interested, to put your name in the newsletter from Ethics4EU and to stay informed of future events and future possibilities. I think this is one of the first steps to try to build this community of practice that we mentioned at the beginning, in particular Dipna mentioned at the beginning. So I think that hopefully we can stay in touch, and then that this community of practice can help, for example, in testing the educational bricks that are developed in the project, in providing suggestions and let's say inputs to this project. So thank you very much. And I guess that if you want to stay in touch, we can do, okay?
And thank you very much to Viola and Informatics Europe for a huge amount of organisation into this event.
Okay.
Thank you.
Okay.
Thank you very much.
Thank you, everyone. Bye.
Thanks to everybody for the
Bye.
participation.
Thank you.